So let's go into the next section here where we'll learn more about how people are regrowing beta cells now.
So I love this picture. Can beta cells grow? We've got all of these beta cells here imaged with this kind of loading screen. Like, is it ever going to load? We're all kind of just watching the pinwheel and the hourglass on our beta cell computer screens, wondering if they're ever going to load. So let's talk more about the regenerative potential and some of the obstacles beta cells face in regenerating and regrowing and maturing. So from day one of being diagnosed, we're told, hey, beta cells don't really regenerate. Once you lose them, they're gone for good. Unlike other cells, beta cells do not seem to be able to divide or repair very efficiently. And if you look here on the graph, I generated this off of ChatGPT, but I asked it to kind of judge beta cells' ability to regenerate versus other cell types. So skin cells regenerate a bunch. I think I've heard that, we regrow our skin like our entire skin like 7 times throughout our entire lifetime. Liver cells, liver is also very regenerative. It's able to regrow. It's taking, it has a lot of jobs, so it needs the ability to create new tissue. Muscle cells, beta cells, and neurons, man, they're just super low down there. Apparently not very good at regrowing. From an immune standpoint, an autoimmune standpoint, and kind of like disrupting the feedback loops at play here, without addressing what's causing the disturbance, whether it be from an immune standpoint or a beta cell standpoint, if we're not addressing the root cause, even if our beta cells can regenerate, if we can't stop them from being attacked, it doesn't really matter. And this bleeds into the inflammation and oxidative stress standpoint. We need to be able to address the root causes of the oxidative stress that are prohibiting regrowth and accelerating the dysfunction of the existing beta cells. So, how do they regrow naturally? This is an awesome graph. I've got it cited here. How, when, and where do human beta cells regenerate? And it turns out there's a lot of different ways. Can you believe this? So ductal cells and acinar cells are 2 of the major exocrine cell types in the pancreas. They are responsible for creating the digestive enzymes and juices. They can convert into beta cells. That's impressive in and of itself. They're not even endocrine organs or endocrine cells like the alpha, delta, gamma, epsilon cells, right? They're in the same neighborhood. Ductal and acinar cells, completely unrelated. Guess what? Given the right growth factors, PDX1, you'll see that mentioned a lot here. PDX1 in just about every single one. That's a insulin growth factor here, and I'll get the exact terminology here. I know it has a name tied to insulin. Yes, so PDX1, also known as insulin promoter factor 1, is a transcription factor. It's necessary for pancreatic development, including beta cell maturation. So there you go. It's a protein coded for growth of the pancreas. There are natural ways to increase its expression. Not wholly unfamiliar, though. It has to do with controlling oxidative stress. It has to do with introducing antioxidants. I know green tea was one of them. Curcumin was one of them. Vitamin D was one of the things that help increase PDX1. But basically, all of the things that you associate with healthy antioxidant dietary influences, they're all doing the right things when it comes to regrowing beta cells. But regardless, the process of beta cell growth slows significantly after early childhood, right? So we are birthed, beta cells are developing and maturing. We are feeding off of our mother. which is not super glucose rich from what I understand. But once we start to wean off of our mother, like year 2, year 3, typically, and we start to eat outside sources of glucose, boy, those beta cells are on fire and they're regenerating very rapidly. And then once we kind of go through that huge stage of growth, it really starts to kind of neutralize. Neogenesis. New beta cells can form from pancreatic progenitor cells. And these are kind of like floating cells within the pancreas, not floating physically, but floating in terms of they haven't been differentiated into a specific cell type just yet. They are able to become beta cells. Hepatocytes, these are liver cells. So liver cells can be converted into beta cells and can help convert existing pancreatic cells into beta cells. Enterocytes, this is from our gut, right? You'll see here that nice little term there, GLP-1. I'm sure everyone here is familiar with that. Glucagon-like peptide. That influences beta cell growth and regeneration. Then you've got alpha cells. Alpha cells themselves can actually convert to alpha cells or can convert to beta cells because of this right here, GABA, right? Just incredible. I was amazed when I saw that graph of all of the different cell types that can help feed, either be converted directly to beta cells or influence their regeneration. And there it is. It's worth looking at on a close up, right? You see PDX, that insulin promoter factor 1. You've got GABA. You've got artemisinins. And I'm trying to think of what artemisinin is, a natural compound that is found let's see. Wormwood, which is very popular in the anti-parasite world. Wormwood is very anti-parasitic, but it also has artemisinin in it. Just really cool. And you know that feeds into the immune system playing a role into all of this. So just really fascinating. So the current research, I'm starting with the natural compounds for beta cell regrowth because that's what I've been focusing on, because that's what's the most immediately available to me. Harmine. I've made a whole podcast episode about it. It is a DYRK1A inhibitor. So this is something that is, Harmine is something that prevents a anti-cell development process, which is the DYRK1A. Pretty cool. And I'm not sure if I talk about it, but DYRK1 and GLP-1 actually synergize to help target beta cell growth. Different polysaccharides found in certain mushrooms like reishi, bee pollen, and particular plants can actually promote beta cell survival, so the retention of existing beta cells as well as beta cell growth and regeneration. And then obviously GABA. GABA can convert alpha cells to beta cells. There's plenty of different ways to source GABA from your diet. A lot of fermented foods, kimchi and sauerkraut are really good sources of it. I think green tea is also another one of them, but I know fermented foods are number one. Small molecule therapies. So there are drugs targeting specific pathways for beta cell proliferation. People are really doubling down on Harmine and the derivatives of Harmine. Combination approaches, like I mentioned before, the Harmine and the GLP-1A, and then stem cells, okay, which I've kind of moved on from emotionally. There are some advances in generating beta-like cells. The only challenge is, by regenerating beta cells, are we actually addressing the root cause of what caused these beta cells to go away in the first place? And if we haven't, we're kind of just like adding, we're taking 2 steps forward without addressing what's causing us to take 3 steps back. So that, I mean, why I focus on natural compounds to begin with, they're accessible. I haven't gotten any of the things that I have now to address type 1 diabetes from a doctor. Have not filled a prescription in years. So I like the social aspect of things in terms of like, this is approachable for anyone, regardless of your standing with a doctor or the healthcare system. You can do it. And it's going to cost less because of that. Reduced risks compared to invasive therapies like stem cell transplantation. You're not going under the knife. You're eating things, or you're not eating things, or you're exercising more. And I like it because it's complementary to existing therapies and lifestyle changes. Becoming more physically active is going to help you on many different fronts, not just a diabetic one. So I kind of like the idea of like, okay, yeah, we need to eat healthy and we need to exercise. It's not just for diabetes, but it has very targeted effects for people with diabetes. This is just a little list I made of the natural compounds linked to beta cell growth and regeneration. So harmine, obviously, GABA, polysaccharides in the reishi mushrooms and the bee pollen, curcumin, which is found the active component of turmeric, berberine, EGCG. I'm not even going to pretend like I know how to pronounce that, but that's what is found in green tea. That's one of the active components in green tea. It's a really powerful antioxidant. Resveratrol, quercetin, omega-3 fatty acids, and vitamin D. They've all shown direct impacts on influencing beta cell growth and regeneration. So that feeds, pun intended, how we can actively support our own beta cell regeneration. So immune modulation, it sounds fancy, but it's really just making sure that we're not doing anything that is over engaging our immune system. So antioxidant intake, reducing inflammation, and giving our body all of the nutritional support it needs to actively fight any pre-existing inflammatory states, right? So we're giving our overactive immune system a break and getting rid of all the toxic byproducts of having had an overactive immune system. Then we get a little futuristic here, right? So there is, from the people have heard my complaints about stem cell therapy in that it's like, okay, well, if you don't protect the beta cells that you're putting in, they're going to suffer the same fate that all the other ones did. And there is this hydrogel. So they're putting these pancreatic islets, they're putting it in this gel, and they're putting it in the body. So this is like protecting injected beta cells from immune attack, which is kind of cool from like a sci-fi standpoint, but it seems wholly unnecessary if we're able to kind of naturally do it with the foods and the vitamins and the nutrients that we're taking in. But cool regardless. This is something that they're going on. I've got the source down there. So there's lots of different things at play here. You've got the specific therapies, whether it be stem cells or the, stem cells in hydrogel. Lifestyle changes are going to be an undeniable facet of taking care of the root causes from a dietary and nutrient standpoint, from a physical activity standpoint, and then from stress management. And then addressing the challenges of autoimmunity, making sure that our immune system is able to recognize the newly formed beta cells as not needing to be attacked. And then what ways can we enhance the slowed down regenerative capacity of our existing beta cells? How can we kind of like light a fire under them, so to speak, without burning them, but just kind of like giving them the notion like, hey, we need more of you. How can we get you going?
So we can clearly see that while there is a basis for our original understanding that beta cells aren't super regenerative and they're not, they're not like skin cells or liver cells where they just spontaneously regenerate, that doesn't mean that they don't have a pretty huge capacity and potential to regenerate. That one graph looking at all of the different cell types that can either directly become beta cells themselves or directly influence beta cells regenerating, it blows your mind. And now it starts to open up the doors to, okay, what are the specific factors that I can influence that are going to drive these different cell types to promote beta cells? And the amazing thing about it is a lot of the major technologies going into regrowing these beta cells is from natural sources. And so that just makes it more and more available to you and I. And with that understanding, okay, we've kind of lifted the pressure off of, okay, beta cells don't regenerate. It's like, yes, they do. They actually do it in a lot of different ways. They just need the right tools in order to do that.